It is not easy to leave your bed when it is still dark, but that discipline becomes your strength in learning. Waking up early is just about having more powerful time. The time where your mind is fresh, your body is energized, and your spirit is quiet enough to listen to your deepest thoughts. When you rise before others, you always stay ahead in life because while they are still sleeping, you are already creating, learning, and winning. This simple habit alone can separate you from the average. And let's get into today's video that is on chi square test of goodness. I have already taught example 1, 2, 3, 4, 5 in my earlier video, and these are the most important questions from 6, 7, and 8. These are damn sure questions. See, let's get into the today's video on today's problem, that is a fair dice are thrown 360 times and the frequency of each sum is indicated below. See, getting a sum 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the frequencies here are given from 8 till 14. See, how we'll get a sum as 2 when two fair dice are thrown. See, let me explain you. And the question here is, would you say that the dice are fair on the basis of the chi-square test of goodness at 0.05 level of significance? Here it is very clearly mentioned that we have to choose chi-square test. And this is also very important. As usual, we have to go with the 5 steps. First one is the null hypothesis. The dice are fair. Alternate hypothesis. The dice are not fair. Level of significance. Alpha is equal to 0.05. The probability of getting sum as 2. So as it is very clear that when two dice are thrown, when we'll get a sum 2. So here in the first die we have to throw 1, and in the second die also we have to throw 1, so that we'll be getting 2 as a sum, that is 1 plus 1 2. So there is only one chance when two dice are thrown, that is 1 by 36. So when we'll be getting a sum as 3, so the first die 1 and second die 3, 1 plus 2. 1 plus 2 is 3 and 2 plus 1 is again 3, and there are two chances, that is 2 by 36, and getting sum as 4, that is on the first die 1, second die 3, on first die 2, second die 2, and first die 3 and second die 1. So this is 1 plus 3 is 4, 2 plus 2 is 4, and 3 plus 1 is again 4, and we are getting 3 chances, that is 3 by 36, and getting sum as 5. That is 1 plus 4, 2 plus 3, 3 plus 2 and 4 plus 1. So there are total 4 chances here, that is 4 by 36, and getting the sum as 6. That is 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2 and 5 plus 1. There are 5 chances, that is 5 by 36. Likewise, I have filled up all these. Getting sum as 12, that is 6 plus 6, that is 1 by 36. And this is how the table happens. So getting the sum as 1, 2, 2, 3, 4 till 12. So this is the probability distribution, that is x is equal to 2. Getting sum 2, 1 by 36. Getting sum 3. So getting sum 3, that is 2 by 36. 4, 3 by 36. 5, 4 by 36. 6, 5 by 36. 7, 6. 8, 5, 4, 3, 2, 1. So this is so easy to remember. 1, 2, 3, 4, 5, 6. And again from 4, 5, 3, 2, 1. So this is how we have to at least remember, or else we have to do it. So here these are all the expected values. In order to calculate the chi-square value, here the sum of getting 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are all the observed values from the question itself. So from the question it is given. See, from the question, these are given as an observed frequency values, that is 8, 24, 35, 37, 44, 65 till 14. So I have mentioned in the column 2, 8, 24, 35 till 14. I have mentioned in the second column, that is observed frequencies. And now we have to calculate the expected frequencies. So here the total value here for observed value is 360. So remember, and the expected frequency here is 360 into P of x. So what is this P of x? And let me explain you. The P of x is nothing but, see here, 160 into. So this is 360 into P of x. So this is the probability, that is 362 into getting a sum 2 is 1 by 36. Clear? So from this table, so we have 1 by 36, 2 by 36, 3 by 36. So these are all the probability distribution functions. So if I cancel for 10 times, the value here is 10. So clear? So this is 360 into this is 2 by 36. If I cancel for 10 times, so the value here is 20. So the next one, 360 into this is 3 by 36. If I cancel for 10 times, the value here is 30. So likewise, so we have to multiply from all these values here from 1 to 36 till, so here 6 by 36, 5 by 36, 4 by 36, 3 by 36, 2 by 36 into 1 by 36. If you keep on multiplying, so we'll be getting this value. So the third column should be filled like this, and the total here is again 360. So here this is 360, and the next one here is, so we have to take, so this is an observed value, this is the expected value. So we have to make a subtraction, that is 8 minus 10 minus 2 whole square is 4, and 24 minus 24, 4 square is 16, 35 minus 5, the subtraction here is 5, and whole square we have to make, that is 25. 37 minus 40, that is minus 3 whole square, this is 9. So we have to fill the column like this, and again we have to do this one, that is OI minus EI whole square, this column divided by this column. So this column divided by this column, so this is 1 and this is 2. So 1 divided by 2, 1 divided by 2. So this is 4 by 10, 0 0.4, 16 by 20, 0 0.8, 25 by 30, this one 9 by 40, this one. So we have to fill the column like this, and we have to make a addition of out of all these columns. So this is very simple if you follow this video, and this is most important question. Now the chi-square test of goodness, the formula here is chi-square is equal to sigma OI minus II whole square by EI. So this is OI minus EI whole square by EI. So here the total summation here is 7.445. And therefore the number of degrees of freedom here is n is equal to here 10. So 10. So here observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 11. See here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here n value is equal to 11. So it is very clear from the given values, n is equal to 11. So here this is 11 minus 1, the value here is 10. And now at chi-square level, see here at degrees of freedom 10, at degrees of freedom 10 degrees of freedom at 5% level of significance, the value here is, this is the chi-square table at the degrees of freedom 10. So this is 5%, 0.05, that is 18.307 is the value. So this is 18.3, and therefore here the calculated value is 7.4 and the tabular value is 18.3. Clearly, the calculated value is less than the tabular value, and therefore we are going to accept the null hypothesis H naught, and therefore we have to accept the H naught, and therefore the dice are fair. So this is how we have to solve. This is very important. And the next question here is the 7th question. This is also, please remember, this is also repeatedly asked a question. And see here, 4 coins are tossed 160 times, and the following results were obtained. The number of heads 0, 1, 2, 3, 4, and the observed frequencies are 17, 52, 54, 31 and 6. So under the assumptions that the coins are balanced, find the expected frequencies of 0, 1, 2, 3, 4 heads and test of goodness of it at alpha is equal to 0.05. So here n value is given as 160. So here n is equal to 160. Small n value 1, 2, 3, 4, 5. So here n value is equal to 5. Please remember this is 1, 2, 3, 4, 5. 5 values are given. So n is equal to 5 here. The probability of getting a head is half and probability of getting a tail is again half. And therefore the expected frequencies here are, see the expected frequencies of getting 0, 1, 2, 3, 4 are the successive terms of the binomial distribution, that is n into. This is n into, this is p plus q power 4. So here the value here n value is equal to 4. So n maximum number n we have to take as 4, I think. N is equal to 4. So here how we have to frame this one? So we have to frame this as, see here the expected frequencies are getting 0, 1, 2, 3, 4 are the successive terms of the binomial expansions, that is 160 into p plus q whole power 4. This is nc naught p power 4 plus nc1, that is 4c1 pq into q power 1, and this is nc2, that is 4c2 into p square into q square, nc3 into p power 1 into q cube, and 4c4 into q power 4. So this is expanded through the binomial expansion. See, as usual, that is nc naught is 1, 4c naught is also 1, 4c1 is 4, and 4c2 is 2 times we have to take a back step, that is 4 into 3, and 2 times we have to take a forward step, 1 into 2. So as we cancel, we got the answer as 6. And 4c3, that is 4 into 3 into 2 by 1 into 2 into 3 into p into q cube, and this is 4c4. So 4 back steps and 4 front steps, and everything got cancelled, and q per 4 remained. And 160 into what is left here, p per 4, this is 4 times of p cube q, and this is 6 times of p square q square, and what is left here, 4 p q cube, and the next one, everything is cancelled here, q power 4, and we have to take the number of heads as half and number of tails as half. And if you keep as half, and if you keep as half as p and q, so this will be the thing, that is 1 by 2 power 4. This is 1 by 2 cube and 1 by 2 power 1, this is 1 by 2 power 4. This is 1 by 2 square and 1 by 2 square, again this is 1 by 2 power 4. This is 1 by 2 power 1, 3, and this is 1 by 2 power 4, and this is 1 by 2 power 4. In place of q we have to keep half, in place of p we have to keep half, so that we'll be getting, so 1 by 2 power 4 is 1 by 16. So this is 1 by 16, this is 4 into 1 by 16, 6 into 1 by 16, 4 into 1 by 16, and this is 1 by 16. So if you send this 1 by 60 inside, that is 1 by 60 into 1 by 16, 1 by 60 into 4 by 16, 1 by 60 into 6 by 16, 1 by 60 into 4 by 16, 1 by 60 into 1 by 16. After cancellation, the first value is 10, second value is 10 fours are 40, and 10 6 are 60, and 10 fours are 40, and 10 ones are 10. Thus, the theoretical or the expected frequencies are 10, 40, 60, 40, and 10. So now, see here, now the number of heads from the table. So here is the table here. So for calculating chi-square, so here the number of heads are 0, 1, 2, 3, 4. So we wrote it in the first column 0, 1, 2, 3, 4. Observed frequencies are from the table, that is 17, 52, 54, 31, 6. So in the second table, in the second column I have filled from 17 till 6, and the next one is the expected value. The expected value is, as usual, I have shown you all these calculations after expanding 10, 40, 60, 40, 10. So here 10, 40, 60, 40, and 10. And here observed frequency minus expected frequency. 17 minus 10 is minus 7, 52 minus 40 is 12, and 54 minus 60 is minus 6, 31 minus 40 is minus 9, 6 minus 10 is minus 4. We have to make a squares out of this. Minus 7 square, 12 square, 6 square, minus 9 square, and minus 4 square. And now OI minus EI whole square by E. So this is the numerator and this is the denominator. 49 minus 10, 49 minus 10, 144 by 40, 36 by 60, and 81 by 40, and next one is 16 by 10. So these are all the values, and this is the value, that is 12.725. See, clear, we got 12.725. So after getting all these expected values and using this table, so this is very, very important, and we got 12.725. Now we have to go with the degrees of freedom. So n is equal to 5, and 5 minus 1, this is 4, and we have to go with the tabular values. So the tabular values will be as usual. So for 4, the value here is, see here for chi-square test, as for 4 is at 0.05 level, that is 9.488. So we got 9.49 and approx value. So here this is the calculated value and this is the tabular value. See, calculated value is greater than, so it is, since the calculated value is greater than the tabular value, and therefore we are going to reject. The hypothesis that the data follows the binomial law is rejected. When the calculated value is greater than the tabular value, we have to simply reject the null hypothesis, and that is how we have to show, and the problem is also very simple. See, all the tables are crystal clearly given in this. So these are the number of heads, these are the frequency values, and this is from the expansion of expansion of the binomial theory, and therefore we got all these values, and after making a subtraction we got this column after making squares and after dividing. So these are the values and this is the total, and this is the total value, that is 12.725, and for degrees of freedom 4 we got 9.49. So on comparing, the calculated value is greater than the tabular value, and therefore we reject the null hypothesis. And next one is the most important one. This is also, so this is on the chi-square test for binomial distribution, and this is for the Poisson distribution. So both are of two kinds and both are important, equally important, and this is also a repeated question. So here, fit the Poisson distribution to the following data for the fitness of, for the goodness of fit at the level 0.05 as usual. So x values are given as 0, 1, 2, 3, 4, and f values are given as 4, 419, 352, 154, 56, and 19. So here this is the table. So this is the table here. So in order to find the lambda, so for Poisson distribution, we need the lambda value clearly. We need the lambda value so that, so these are all the f values and these are all the frequency. We have to multiply fx 0 into 4190, 1 into this one, 2 into 154, and 3 into 56 is this one, and 4 into 19 is this one. So here is the total, that is 904. And therefore for finding the lambda value sigma fx by sigma f, so the value here is 905 by 1000. The value here is 0.904. 904. The theoretical distribution for is n into p of x. So here n value is equal to 1000 here. That is 1000 into p of x. What is the Poisson distribution formula? E power minus lambda into lambda power x by x factorial. Clear? And what is our lambda value? Lambda value is nothing but 0.904. Clear? And therefore we have to mention all these values. And for x values are these one, x values are 0, 1, 2, 3, 4, and so on. And therefore, so we have to frame a table here. So the lambda value is very clear as 0.904, and the expected value here is n into p of x. N value is 1000 into e power minus lambda, lambda power x by x factorial. And what is our lambda value? Lambda value is nothing but e power minus 0.904, and here also we have to mention as 0.904 par x by x factorial. And here, so this is the table which we have to draw. X values are 0, 1, 2, 3, 4 from the question, 0, 1, 2, 3, 4, and these are all the frequency values. So these are all the frequency values. The expected frequency is nothing but 1000 into e power minus 0.904 into lambda power x by x factorial. Here x value is 0, 0 by 0 factorial. Here lambda power 1 by 1 factorial. Here x value is equal to 2. This is 2 by 2 factorial. And this is cube by 3 factorial. Power 4 by 4 factorial. This is the lambda value. And after substituting in the formula, so this is the formula here. It is very, very important. E power minus lambda into lambda power x by, this is x factorial. So this is 1000 n into. So for each and every value of x, we have a value here. So I'm going to show you the value for 1. I'm going to show you how to solve this. So this is shift in minus, this is 0.904. We got the value here into, so I'm showing this one, that is 0.904 after making an into this value is 1000. The value here is 366. The value here is 366. For the next value also I'm showing this one for 2, that is shift in minus, this is 0.904 into, this is 0.904 square divided by 2 into 1000. The value here is 165.4. So likewise we have to fill this column, and the next one is OI minus EI. OI is 419 minus this one is this one, and 552 minus 366 is minus 14. 154 minus 165.4 is this one. So we have to fill the column like this, and we have to make the squares. So we have to, you can make simply squares as, so here see, this is 14.1 square. That's it. That is 198.81. So we have to fill with the squares, this column, and the next one is this column divided by the expected value, this column, that is 198.81 divided by this one. We have to fill the column like this, and we have to make an addition, that is 7.81. And now see here, after filling this column, see, each and every column is so important, you don't miss anything if you follow this video. So in the textbook straightly it was given, and therefore I have drawn for you. In the textbook, the straightly the values are given, and therefore have shown you how these values has come. And these are the columns. Please remember, that is, first one is x observed frequency, expected frequency, oi minus ei whole square, oi minus ei whole square by ei, and these are the tabular values. So here, in order that the total observed and the expected frequency may agree, we take the first and the last theoretical value as 406. So here 406.2 is taken, and 12.6 is taken instead of 404.1. So here the actual value here is 404.9, and here also this is 11.3. So here, see, in order that the total observed and the expected frequency may agree, we first and last take. So these first value and the last value are taken as 406.2 and 12.6 instead of this value, that is 404.9, and this one is 11.3. We got 11.3. In place of these two, they have taken, this is 406.2, and the next one is in place of 11.3. In place of 11.3, they have taken 12.6. They have taken 12.6, and they made a table here. So what is the reason here? In order that the total observed and the expected frequency may agree, in order to agree, they have chosen these two values instead of these two as shown in the brackets. Hence, after using these, so we got the chi-square value. If you take these two and make a table here, so we got as 5.747. That is 5.748 we got. So this is the actual value, and we have to take these two in order to agree the expected value and the observed value. So as this is the textbook solution, I am giving you explanation, and therefore the degrees of freedom here is n minus 2. Why it is n minus 2? I have already shown you one thing, as there is a note here in the chi-square test of goodness. So there is a note here, that is for binomial distribution n minus 1. For Poisson distribution, we are doing a Poisson distribution problem. This is n minus 2. So here n is equal to 5 minus 2, 3, and the degrees of freedom here is 3, and we have to go with 0.05 level of significance. As for 3, 0.05 level of significance for 3, this is the chi-square table. At 3, at 0.05, this is 7.815. So this is a 7.82, and we got 5.748. So there is a variation here. So here the calculated value is this one, and the tabular value is this one, and therefore the calculated value is less than the tabular value, and this agreement between the fact that the theory is good, and hence the Poisson distribution can be fitted to the data. And this is how we have to solve. So as these three are the essay questions, they took a little bit lengthy video as this is, and have patience, and please observe each and every point which I have clearly explained, as so many steps are skipped in the textbook. I have given you each and every point, vividly explained, and directly have solved, and this will be very helpful for your preparation. Thank you so much for watching. If you really like, you know what to do. Please practice, and please go through the playlist, and so many videos are uploaded directly from the textbook, and it will be very helpful even though you don't carry a textbook. Thank you so much.